So here, although the hydrogen bonds to bromine here, it does not bond to bromine here, it bonds to the oxygen being more electronegative. So this would be the structure of this. What would the geometry of this one be? Molecular geometry. Bent. Okay, now here in HBrO2, we're going to have bromine as a central atom here. And this is going to result in some formal charges. There's 0 formal charges here, 0 formal charges here, but here we're going to have some formal charge. What is it? And so we're going to get a minus on the oxygen, and the bromine is going to have a +1, actually. Because bromine should have 7, and it ends up with 6 in that particular structure. And so for this particular structure, what a lot of people do is they will do what? A lot of people do when they draw this structure is they'll double bond this. If they double bond that oxygen, then we end up with 0 formal charges, but then we have to expand the octet on bromine. And so HBrO2. So it results in something like this. Here. This is going to be bent because we got tetrahedral, EPG. You know, single bond, double bond, lone pair. It's 4 groups. 2 bonded atoms, so it's going to be bent. Here they expand the octet on bromine from that double bond. If we go to HBrO3, this would be the structure with not expanding the octet. If we don't expand the octet, this is what we get. However, the formal charge has not been minimized here. Well, the formal charge would be what? 0, 0. Bromine is going to be plus 1, 2, 3, 4, 5, plus 2, and this oxygen is going to be minus and minus. And so if we don't expand the octet, that's what we get. And the structure, well, this oxygen would be bent, this bromine would be trigonal pyramidal. We could expand the octet and get rid of by forming how many double bonds? 2. And so let's see what people do. HBrO3. And let's take a look at the structure. What does it look like? With HBrO. Was that HBrO2 or HBrO3? Looks like people are writing in how many double bonds? 2 double bonds. Like I said, this is not the. What we're doing here is valence bond theory. If we wanted a more accurate picture, it'd be what's that theory called? Starts with an M. Molecular MO theory. Call it. There's a lone pair here. That's why this is trigonal pyramidal. They aren't doing wedges and dashes here, but when you do a wedge and dash with double bonds, it's a hassle. You got to draw 2 wedges here and then 2 dashes here. So it look kind of funny. But for you guys, you could just leave it as octet. Your book leaves it as an octet. You could leave it as an octet too. So this structure is perfectly fine. Just leave it like that. This would be HBrO4. Again, hydrogen is going to be bonded to the oxygen, the most electronegative here. Except bromine. What's the formal charge on bromine? Plus 2 is wrong. 3. Plus 3. And each oxygen is -1. So the formal charges are starting to get pretty high. Those are what we would call high formal charges. What's the geometry around bromine in this? Tetrahedral. Now, if you expand the octet, this is going to be hugely expanded octet, which might not be so easy to do. You know, but you could get rid of the formal charge by hugely expanding the octet, but hugely expanding the octet could be difficult to do as shown in the Lewis diagram. You know, they're forming how many double bonds? 3 double bonds. It's a lot. Double bonds. It's going to be tetrahedral. It's a tetrahedral structure here. You see one double bond, another double bond, another double bond, and this kind of tetrahedral type arrangement here. And so drawing these, again, you do double wedges, double dashes, that kind of thing. Here's more of a 3D structure there. All right, let's stop. We'll take a break for right now. So. I'm sorry?
The oxygen doesn't go on the bromine.
Oxygen does not go on the bromine because you need it on the most electronegative. The oxygen or the hydrogen? Did you say oxygen or yeah. You want the hydrogen on the most electronegative element. And so it's not going to go there. That's to make it the most acidic possible, but it just doesn't go there. It's more favored to go on the oxygen. These are called oxyacids. HBr, however, is not an oxyacid. There's no choice. You got to put it on bromine.
What was it called? Oxy what?
Oxyacids. OXY acid. Oxyacid. You go to Wikipedia, we could look at the oxyacids. The lots. It's in the dictionary. Yeah, oxyacids. Read about them. Yeah. It's electronegativity. There, where is it? Do you know which one of these is going to be the most acidic? You might think they're all the same in terms of acidity, but they aren't. I'll talk about it briefly and after the break.